We will now carry on until 12:30, and then we'll break for an hour. Sometimes you think these sessions, it's too long to break for an hour for lunch, but that's also when you get to discuss with each other, and it is to last a week with just one session after the other is a 3-day is manageable. A week becomes quite long, and we have to balance it out with a lot of practical. Otherwise, I can see you will doze off on me here. Okay, so there's just a few things in the Woolrich chapter that I feel links nicely to to where we're going with this. This whole idea of a static model, where it is simply inflation in the current period as a function of unemployment in the current period. But are things as simple as this? Or can we model everything just with static models? Or does yesterday, what happens yesterday, matters for today? Does inflation yesterday or last month or last quarter matters for the inflation rate today? We do believe dynamics matter. Your income plays a role in how much you consume this period, but also the income that you earned previous period, and so forth. Another, just a static model that Woolrich suggests there is the murder rate in the current period can be is determined by the current conviction rate, unemployment rate, etc. But can it not only also be the conviction rate that we see is actually discouraging people to commit crime? So, maybe a static model may not be the best, especially when we deal with stock market, financial markets. That many economic processes are highly autoregressive in nature, very persistent. So that may even be the most important determinant of the stock market today, and not so much other variables. What is included in this example is presidential approval ratings and macroeconomic control variables. So that's another example given. How about this one? This is an example that Woolrich give there. The fertility rate is a function of tax exemptions, because it's not like you decide you want to have a baby today and then you just go to a shop and buy one. There's a lag there. But is this how we model? Because what will happen if you really run that regression? What violations of the classical assumptions will appear? We're likely going to see what violation? Multicollinearity. These variables will move closely together. If they have a certain trend, they just shift back one period. Just like having consumption as a function of income in the current period, but lagged income as well, or lagged wealth effects. So specifying a model like that, we almost know by the outset that we're going to have a misspecified. It will have a violation of the important assumption of multicollinearity. So that is a little bit old school. Who of you even know, have you ever seen that?
Yes.
Maybe just so that's the way we used to do it, but then we made it a little bit better. And listen how I say we, because I was still part of that generation. So we then to avoid the problem of multicollinearity, we started placing weights. And typically, the current period will cover the highest weight, and then you can just weigh it 3-to-1, or if you think it's a linear. But this is very subjective. There was also the Almond lag structure that you could apply. It's was a little bit more scientific. And Almond, by the way, was one of the few. These days we have a number more, but a woman researcher. So the Almond lags was how we approach this. So then instead of including all 3 lags, we just include that weighted variable there and take that as the parameter then, the marginal value or the elasticity if it's in logs. But now with the co-integration approach, it's almost as if things happen very smoothly. It's now like having all the music at your fingertips. So we can address that easily by any of the co-integration methods. And what is good is that using a co-integration method relies on very core economic principles, that we believe any market that there is the so-called steady state where the market will be in equilibrium, where demand and supply equate or when the right price, the equilibrium price is a result of demand and supply, or whatever we busy modeling. But furthermore, it can accommodate and very easily the fact that models are dynamic. And in the most basic method, we do it in 2 steps. We first try and model that so-called steady state, that long run, which is an average over a number of periods. And then we model, then that error term of that long run relationship represents the degree of disequilibrium. If the model fits 100%, then the model is in equilibrium all the time, every single period. But each time you see a deviation, when the error term, the residual term is above or below 0, there's some disequilibrium. And then we model that forces that will, if something leaves the system in a disequilibrium position, that will bring it back over a number of periods. And that sounds like a win-win, right? So then we don't have to worry about what is now the best way to model these, because we will do it, I wouldn't say automatically. You're still the pilot of the ship, but there's an easy way to model that. And although there are many different techniques, for the most part, I think many economists, what we do is based on linear regression analysis. Obviously, there's also a body, and in doing this, what we do as frequentist economists or statisticians or whatever, the null that we put, the null hypothesis that we put on that parameter. Firstly, if we run regression analysis, which direction do we assume causality runs? By putting y on the left-hand side and making that the regressant or the dependent variable, we already assume that there's causality running from x to y. We assume that. How often, if you grade students' papers, I'm sure many of you are lecturers and assistant lecturers, that if you ask them to interpret that relationship, and this is growth and this is inflation, instead of writing about inflation affects growth, they start writing about how growth affects inflation. And you cannot do it by looking at that result when there are numbers there. It may be true that in real life there is a bidirectional causality, that's simultaneity, and that is a violation again. So that makes our life a little bit difficult. In a micro context, we often have instruments to break that statistical link. In a macro, it's more difficult. If you have GDP and you have investment, how can you find an instrument that is highly correlated with investment but not correlated with GDP? So that's just going to a simple using instrumental variables to fix that is not always easy. That's why we have GMM, so that we look for instruments inside the model, but that's not always so well received by reviewers and the scientific community. So there's a lot of things to consider here. So apart from possibly having a bidirectional causality, that simultaneity, what else can go wrong? Just omitting another x variable on that side can already present a problem as well, which can also lead to violations of the zero conditional mean assumption, or in another way of mentioning that is the exogeneity assumption, that all x's are exogenous and not related to the error term. So we'll get to that just in a second. So you can see this goes actually back quite a while, but sometimes I think about in the whole existence of the world, that's like a very small drop in the bucket of. So that's where it dates to the technique that we use. Obviously, they are, what I also wanted to say, in frequentist economics, we set that parameter as equal to 0. And the alternative is then, so we almost put what we believe in the alternative. So we can always just say that, so obviously then we want to reject, but if we reject, it will always be subject to that type 1 error, the probability, that alpha that we set at 5% or 10% or 1%. How is that different to the Bayesian approach? Kenny, in the Bayesian of, yes? We actually put in the null what we believe is true. If we believe this is how good a medication will work and the impact, so you almost put the value that you expect there as a prior, and then you calculate the posterior. So it's just the opposite. So you're more certain about the outcome. So in frequentist econometrics, we always deal with that uncertainty. So that's the one thing. And then the other thing is what Sean mentioned. How sure can we really be that there's a direct causal relationship between the y and the x? And it's not just a correlation or an association, that so-called spurious correlation. Because what gets in the way here? There's sometimes it can be that there's a third variable, a compounding variable, or a common underlying variable that drives both of this. Sometimes you see examples like ice cream and shark attacks, ice cream and sunburn. Because you see a lot of people walking around eating ice cream, and then you hear now shark attacks are. So is there or is that a spurious correlation? It's one of those things that maybe summertime on the beach is when people eat the ice cream, they swim, they get eaten by a shark, or they get sunburned. And often in economics, that's also the case. Or there are intermediary variables. Yes, we can almost claim that climate did affect output, or interest rates affect growth. But it doesn't happen directly. There's a whole transmission mechanism to get from interest rates may affect the way people spend. That will lower demand, that will lower prices, etc., until we get to a point that it starts positively affecting growth. So when we write up our results, sometimes it's good to keep that in mind and not to sell it so directly as there's definitely this causal relationship, and if this goes up, that goes down, or whatever. But just, especially if we start using a number of cross sections, so we have a whole panel, that parameter is then not only an average for the whole period that we're dealing here, but also across all the different countries.
So just assume that you don't have the economic theory, and you're looking at a model. Is there any way statistically to see if there's an unobserved variable having an impact? And you don't have the economic theory to actually think about it mathematically. Is there a way to actually try and tease that out?
If you analyze that error term, you will probably pick up heteroscedastic patterns. They all serially correlated patterns. Say, for instance, I run some kind of a demand function, but I leave out income. That then, say you just model the way I'm going to consume as a function of my price expectations of the following period, but my income is left out. Then that effect will end up in the residual. And there's an example that I will show you a little bit later here, which if you then include a trend, suddenly everything works. But it's that trend is very similar to the income. So many people work with the residual structure to get an idea of what can be wrong here, and then use that also as a measure for especially some of these unexplained uncertainty, sentiment effects. It goes and hide in that error term. And I'm still sure you remember how OLS works. I don't think we have to get to our main objective here. But what are we basically doing? How does OLS give us that beta hat and beta 1 hat and beta 0 hat? For the OLS, it is simply plotting so if we have one y and one x variable in a flat two-dimensional space, you do a scatter plot, and what it effectively do is like taking a string and fit it as closely as possible to all those points. So if you move it a little bit and it's then closer, and by closer I mean if we add up all these little differences, so if these are, how did I get here? Sorry. These are all the combinations of y and x. And we can see generally higher values of x is associated with higher values of y, so it's a positive relationship. So all these deviations, so we want, if we sum them, but in absolute terms, when the point where those are the absolute minimum, if we square them and sum them, that will be the best fit for this line. Why don't we just sum them as it is? Because if we fit a straight line through here, those lines will be above and below will be much larger, but that will be a lesser fit. So we sum those and we add it up. And if we start going to higher dimensions, if it's if we have 3 variables, we actually fitting a plane, or like if you take a page and you think about the y, the x, and the z axis, and we actually fit a flat surface in that 3-dimensional space. And if we go to higher dimensions, then we rely on the calculus to do that. So what we basically do is just to minimize those little distances by summing them, squaring them and summing them, and then we want to minimize them, and we're doing so. Of course, if we add them up, it will always be 0, but the square differences should be a minimum. And what we do is, what we want to minimize is the squared residual, so we want to minimize the actual minus the fitted. And how we do that is to taking the derivative of that with respect to the 2 parameters. So we take equation 2 and then take the derivative to the intercept and the slope parameter. And then, of course, if you remember the calculus rules, the constant goes to the front, and then we get that equation. And in this case, we also have an xt that goes there. And then we simply solve that. And what we get is the 2 parameters will always be as such that the beta is the intercept and the slope but it will always go through the averages of X and Y. And now we get to the question of the difference between causality and correlation, but first here just some terminology which I'm sure you are all, this is like, I'm sure you teach that to your first year students, the marginal propensity to consume and the autonomous consumption. But not in all relationships do we give these elasticities and intercept parameters names. What I want to look at is this, and that question. I think when we do analysis, we're so eager to get to a point that we say, this thing definitely causes this thing. We want to claim it. However, very often what we find is merely the bigger circle, the association. We see that countries, and I was just listening to a YouTube a lecture or a speech that one of the Harvard professors at the business school, he teaches the economics of happiness. So we might feel, especially the men, is like, why? We have bigger things to worry about than happiness of people. and then he says his class is actually quite popular. Students want to attend the happiness class. But it's a whole scientific, it's not just that feeling of feeling happy. That self assessment or that self proclaimment of life satisfaction or happiness. What really is that? What is driving that? Is it support structures that we have? Is it income? Because if you just do a plot of countries overall using the United Nations project of the Happiness Project, where Jeffrey Sachs and a whole number of people, Jeffrey Sachs from Columbia University, they did this project back to 2005. And then they look at many dimensions of this concept of subjective well-being or happiness. But is the story, does money buy happiness? Is income the key? I'm sure it does help. I mean, if you just plot, if you look at those, the graphs, the high income countries will also rank quite high on the happiness index. And the lower and the less happy countries ranks lower on the income. But here in Africa, we're much happier than our income should. And then there's all those theories about the happy peasants, and I don't know, all those hypotheses that people test. But that's one example to me that can we say that income directly contributes to that? Can you put happiness? Can you put income in that place and find happiness here? Or is there much more going on? Maybe it's one component, but then having good social support, access to good health, health support. And what else? The happiness report, they look at quite a large number of contributing factors. And that whole happiness of economics, different genders have different levels of happiness, and also marital status and age. By 40, apparently, people are most unhappy. I think you think what you would have achieved by then, and you realize, no, I'm not there, and then you just let it go, and you
Midlife crisis.
and you feel happy. Yeah, so that's one of the cases that I think it's either some underlying variable or intermediate variables or something like that. So telling that economic story is not always as easy as thinking about this example where we have a Keynesian consumption function. But then also researching this is quite boring. So if students come to me and said, will you supervise me? I want to do this, and it's really one of these boring subjects. I say, no, we can do better things. Really, so so the difference between a correlation and it's maybe also not so easy to see it here, but except for the correlation coefficient, the row between x and y is the covariance of x and y over the square root of the variances, so the standard deviations of x and y independently. But here we can see that when we run the regression analysis, it's more than just a correlation. It's also a causal impact of a change in x to a change in y. So just running a simple pairwise correlation coefficient, this happens to be quite, and you can see when I take the logs, they stay quite close to that line. If we do it without the logs, and you have the data so we can check that, it tends to move a little bit further away at higher values because of that nonlinear trend that we see a little bit. So this is highly correlated, but can we use that to say that a 1% increase in income will lead to a 0.99% increase in consumption? No. It just means that the XY pairs are quite close to that line, and it is positive. So it helps when you start out with analysis to graph the data over time. Do the XY graph, see how strong that relationship is, look at the correlation. And that's already an indication what you're going to find way down the line when you start running the regression models. Yes?
Thank you. On the subject of correlation and causation, is it possible to not find a correlation between two variables, but as you do further analysis using any econometric model to be able to establish causation?
Did you hear what he said? Is it possible not to find correlation, but once you then run the regression, you find causation? Much of it will be luck. A little bit will be imagine, I don't want to write on the board and make it dirty. imagine a plot and those dots are just all over, right? Some high values with some low values and some low values with some high values. Which line can fit through a cloud of dots like that? Any line. Positive, flat, negative. So basically the correlation will be almost zero. So you don't have a correlation, right? So anything like, I don't know, it differs in these macro type applications. It's easy to get, since the data has got these trends, it's easy to get a high correlation. In more of, I guess if you use social variables, you get spreads of income levels and other outcomes, and so it can have a weaker relationship. Then if you start running, that should already be an indication that you're going to struggle to tell the story. In the export example, I will show you during the period of sanctions, the relationship quite exactly did break down. You can set your price as high or as low as you want. If your trading partners said, for now, we're not buying your oranges or your wheat or whatever, gold, you do get a breakdown of that relationship. Sometimes we try really hard and we sweep this under the carpet and just say, look at my regression. But it's sometimes just a function of all the ingredients, especially in a panel that you've thrown in there. When we started with a student, we try and now investigate that trade uncertainty on financial stress. That is the first and the second moments of what's going on in the financial markets, plus some other things about the bond market, but mainly stock returns and stock price volatility. And we did see what happened in the US, across the world, just recently, with the announcement of the trade sanctions. The stock market dropped significantly, bonds started going up. So when we started running that, and we had data back for 40 years, including the global financial crisis, and we keep on getting, so what are we believing? Trade uncertainty goes up, what happens to financial stress? Also go up. But now we keep on seeing a negative relationship. So high trade uncertainty, low financial stress, and the opposite. But then if you just plot the data, during the global financial crisis, the financial stress index, what happened now this last is like almost like a little blip comparing to a mountain. So obviously, now that trade uncertainty is high, that is true, but that period, including the period of the global financial crisis, then makes that is causing us not to find that positive relationship. So when we then started actually just looking at what happened from 2016 onwards, when we started seeing these trade wars, that's the tariff wars, that was the first time we actually start hearing these terms. Now suddenly we get the results we expect. And then especially if you then start using a quantile regression, you see for the higher quantiles of trade uncertainty, the results are stronger. So a little bit of trade uncertainty doesn't affect the stock market, but higher, or the bond market. But as soon as it gets to the higher quantiles, we see the impact. So does that answer your question? I've now talked so much.
Yeah, it does.
Yeah, so for the whole period, we don't, and so, in all honesty, in panel, you can torture the gecko to confess to be a crocodile. You can, if you put in the right combinations of variables in that growth model, you start getting the results that you expect. But it all goes down, if it's not in the data, you like just borderline getting those results. And sometimes that is the story. The world doesn't behave exactly the way we want it to. Actually, as a matter of fact, the contrary. So, but it is our job to tell that story then. Yes.
In terms of the number of observations,
Mhm.
what kind of data set did you use from 2016 to the same area?
That was for that example of the financial stress in relation to trade. Yes, the reason why we looked at we looked at just post financial crisis, but when we started looking at the first presidential term of the Trump administration, which started the trade uncertainty for the first time with that, but then it was mostly with China. Then we get the results. It was very high frequency. The stress, I think the financial stress is weekly or daily, but the trade policy uncertainty is a little bit, but it's high frequency, a lot of observations. Yeah, so obviously we want that rho or that R to be closer to 1, but it can always be negative, so in absolute terms closer to 1. So the null is actually, like we do in frequentist econometrics, we set it as null, but actually we want the correlation to not be 0. We want it to be close to 1. So, and that p-value that we get, that associated p-value show us at what level we reject the null that it's 0. We reject that literally at the 1% level. So it almost seems a little bit silly to even say which way does the causation run, but it's often not so sure. If we think about one example that's often used is murder rate and the number of police force. Which direction does the causality run? We see increases in police force, we see increases in murder rate. What's the mechanism there? Which caused what? Did the police now help to murder people? What? You see, what is the story?
No, if I may speak,
Yes?
the increase in the number of police officers is a reaction to the increase in the murder rates.
So the murder rates first go up and then we hire more policemen.
Yeah, it's like a reactive policy.
But how about, since there are now much more law enforcers out there, they catch the criminals.
Yeah.
So what is the chicken and what is the egg? So that's one of the textbook examples where we have to instrument. Mostly we model crime, and then we have to instrument that police variable. Yes?
So like, according to my understanding, I can depend on the data, what data we mentioned.
Yes.
What
Yes.
like, specific data.
You nail it on the head. That shows how important that economic background, economic theory, is, and also your knowledge of what.
It's like a trend option. Even that legislation part.
Yes, yes, yes.
In other words, like the way.
Yeah, there's not there is some economic tests that we can help us, but it's not. You have to put that a large dose of economic theory and knowledge about what you're modeling. So I think before we get to the causality test, the one on the left-hand side is always endogenous, and this one to this one equation model is an exogenous variable. We can endogenize income if we add an equation and to say, how do we model income? And disposable income, again, is then a function of some aggregate economic variable. Like it typically will move in step with the GDP. So, but it can also, obviously, you can model it as a function of employment rate and oops. This is a Granger causality test and not necessarily applied correctly. There are a lot of problems with that slide. But what we can see there, how in the simplest form, and this Granger test is work that Clive Granger did in the 80s. He got acknowledgement of this alongside with Engel Granger for the integration method that they suggested, and Engel Granger, Robert Engel also got acknowledgement for his volatility models. So in the simplest form, what we do here is to set up a VAR model, a vector autoregression, where we have two equations. If we have two variables, then we have an equation for consumption and an equation for income. And consumption is then a function of income lagged by 1 period, 2 period, up to how many periods make sense, and consumption lagged by 1 to how many periods. Typically, if we decide on a VAR of order 2, we will say consumption is a function of consumption t minus 1, t minus 2, income t minus 1, income t minus 2. So that's one OLS regression. And then we have another equation. Income is a function of consumption lagged by 1 period, 2 periods, consumption lagged by 1, consumption lagged by 2 periods. And then we looked at the F-test of the parameters in the, just want to see, maybe it's in here. I don't think I put it in the slides. It's later on in the slides. I just look at if lag consumption is significant in explaining current income, or is lagged income, the income that you earned up to this period, is that significant in explaining consumption today? What do we expect to see? Income causing consumption, but not consumption causing income. That will mean because you spend so much, now you have to go and work double shifts. But it's not possible for many people. So the null is, just read the English. Income does not Granger cause consumption. And then we reject that. The p-value is smaller than 0.01. Consumption, so what we then conclude from that, and also we have to word that carefully. It suggests that rise, and it's not even, Another problem with this type of work is it can't say anything about the sign. Does increased income lead to increased consumption? We need other tools for that as well. But it does show a significant impact of increases or of changes in income in previous periods to consumption in the current period, but not the other way around. That p-value is 0.38. So we failed to reject. Have you used these type of Granger causality tests? There's actually very nice tests available now that can tell you period by period. Especially if you think about how does climate impact certain variables. Maybe historically it's not significant, but now with more and more adverse weather patterns, it does affect agricultural output, and that can in turn affect geopolitical issues with resources and. So having those time-varying Granger causality is actually quite nice. Yes?
Well, I want to find out, like, for example, the one I was doing my own spec 2-3 years ago, like, they said all the time when you try to interpret the relationship between variables,
Yes.
you have to indicate that you hold other factors constant.
Yes.
So to us, in this regard, rather when we see examples, it's important for us, maybe like, even right to say that holding other factors constant, including the factors that involve the consideration of other variables, which may not be included.
Yes. Yes.
So now my question is, there is an important need, like, to highlight the ways holding other factors.
Yes.
Other variables constant.
Yeah. Yeah. I believe even in because a VAR is just to OLS regression, and it's actually estimated independently, not as a system. When we even if we do the reduced form with the impulse responses, to start out with, the equations are estimated one by one. But definitely with all regression results, it is assuming that if you zoom in on one parameter for that moment, you assume if y is a function of x1 and x2, if you look at that, the parameter of x1, say it's beta 1, it assumes that you can then say a 1 unit or a 1% increase in x1 leads to a beta 1% change in y, keeping x2 constant. And I guess by extension, everything else that's not there, everything that ends up in the error term. So it's just highlighting that one variable that we look at.
Sorry. So in your example, the beta 1 and the beta 2, let's say we just left out beta 2, would there be any influence on beta 1? Would it change in any way?
Yes, it will impact that beta 1 parameter through violation of the zero conditional mean condition, because that it's now an unobserved effect that will end up in the error term.
Okay, so it can impact beta 1 and the error term as well.
Yes, through the error term.
The error term.
Yes.
Thank you.
So once we do this, and imagine now, I mean, any research that you do will hardly be as simple as that. But when you have that, what is the first question that you ask? Even if you have 5 variables here. Before looking at, let me ask that. Sometimes I ask the honors students when I get them just from the stats department. They are trained very well by statisticians And I ask him, what jumped out at you from that result? If you have to mention one thing to me about that result. What do you think the students tell me? What they will say, look at that great R squared. Or they will say, look at the T stats. It's almost too good to be true, right? It is too good to be true. There's a reason there. However, if we take our statistician hat off and we put our economist hat, what question do we ask? Does that make economic sense? Does it make sense if you earn 100 Rand more? Are you going to spend 86 Rand and save 14 Rand? Is that a reasonable behavior? Keeping in mind that this is true for the past 63 years. That's already a limitation. To say average over the past 63 years, the South African consumer, for each 1 Rand additional or 1% additional income, we spend 0.86% more on durables, non-durables, services. Does that make sense? And has that changed over time, maybe? Yeah, that's a factor, right? I get such a fright if I see the grocery bill. Yeah, that's part of it, but also I think a generation or two ago, people were definitely saving more. I remember my parents saving for a car and then buy a car, and saving for a holiday and then go on holiday. And what do we now? We just check our credit card balance, or we just call the bank and say, I've seen a car, I like this model, will I get finance for it? Which is, I think that there's a behavioral change there as well, but I think part of it is really life has gotten more expensive. So we have techniques that can help us model that. Recursive estimation is the simplest way, by starting with just the first, say, 20 observations, and then add one observation and see what was it if we consider from 1960 to 1981, 82, 83, 84. And each time you see that beta parameter develop, increase or decrease, or increase and decrease. And then you can say something about behavioral changes. Think about production that uses capital, labor, and maybe other production factors like land, or if it's agriculture, fertilization, rain, whatever. If there's a change in, let me ask, is there a change in contributions by the different production factors over time? Maybe there has been a move towards technology and capital away from labor. Then we will see that in that labor elasticities and capital elasticities. So the simplest way to do that is to do recursive estimation. And for most softwares, you just put it in a loop, increasing the final time period, and then make a nice graph of the parameters. And then you can say something about how it evolves over time. The more sophisticated technique is to use the Kalman filter, which is a state space model. So you have a measurement equation and then you have a transition equation, how the independent variables develop over time. So then you can also get that development. And the Kalman filter, the state space modeling, which was originally designed to actually help in state space technology, putting a satellite in an orbit around the Earth or putting a rocket on the moon, whatever. You know, when this technology is launched, there's some digital equipment that takes measurements every nanopicosecond and adjusts the path of the satellite or whatever. And so that dates back to 1969 when Kalman developed that technology. And now by the 80s or so, economists said, but isn't that how our brains work? You're bombarded with information on an hourly basis every time you take your phone out. Just to maybe look at the time, there's some notifications, and you see information. And you may use that to form expectations about prices, other economic outcomes. So that's another way to model that marginal propensity to consume over time, if you're interested. Because I think that matters. It's the sin goods. How does demand for cigarettes or liquor, how does that change over time? How price sensitive are we for demand for certain goods? But otherwise, we have a limitation that is an average for the whole period. And it is, in any case, these are aggregates across, it's a national aggregate, and it involves durables, non-durables, services. So that's already behavior are different for different categories of these goods. So having a breakdown then can give us more information. So once we have that question there, we answer by going through this and tick a few boxes. Does this look familiar? A set of boxes that we want to tick. Not the most pleasant part of econometrics to learn, but quite important. And if you do a course, they often make you derive all of those and prove all of these assumptions. So what should be true if we have that y as a function of x1 and x2 and x3? Firstly, it must be linear in the parameters. What does that mean? And now I wish I can write. I can write on there, but then I have to break out of the full screen view. Let me just try and talk it, and then you can imagine it. If I have a function, a Cobb-Douglas production function, y is equal to a k to the alpha, l to the beta. What do we have then? It's a nonlinear production function with alpha, the labor elasticity, and beta, the capital elasticity. But that I cannot model because it's not linear. Let me just break out. So many relationships in economics are actually and then of course we have e to the power of u. So OLS will not help us to model that. But as soon as I log linearize this, now it is linear in the parameters, and those are my capital and labor elasticities. And this log A is our total factor productivity or whatever. And as soon as we start using, and we can just call that A, it's just a number. So OLS will give us one value for A, one value for alpha, and one value for beta, which is the average for the whole period. But then with using recursive estimation, or rolling window estimation, or state space modeling like the Kalman filter, we can actually start saying something about the contributions of the production factors over time and how technology developed. And if it is agriculture, maybe we want to say something about land and rain or other factors. So that's always a test, that if the relationship is not linear, how if I have y and then it's a function of 1 over x? Is that permissible? Y is equal to beta naught plus beta 1, 1 over x.
That's just x to the minus 1.
It's 1 over x. Is that linear in the parameters?
Sure.
It's just beta in front of that, right? Not beta square, beta something else. So it's still linear in the parameters. Sometimes you will have something is an inverse relationship of something else. Instead of expecting a negative, you can do it 1 over x, so that it's still acceptable. So what we want to see is the betas is not a complicated function. The betas must be just, whether we call it beta or any other Greek symbol or any English letter, doesn't matter. And then that perfect collinearity, that is when in the model y is a function of x1 and x2. x1 and x2 may move closely together. It needn't be perfect, will be, it's almost the same variable. But if it's correlated enough, that is a problem. Think about you model investment. You want to include a variable on the right-hand side, but now you're not sure about having GDP at market prices or GDP at value added or any other aggregate income variable. And just for safety, you put in both. Is that good? Is that a good thing or a bad thing? I have investment, so I put GDP at market prices and GDP gross value added, the gross value added figure. The difference between the two is subsidies and taxes, but they're very much highly correlated. If you run that regression, you will get a great R squared. But what happens to the t's? Very often both of them will now be insignificant. So if you run, especially if you run panel data and you see, I have a fairly good fit, but variables, I know income matters for investment or matters for consumption or whatever. But now both of my measures are insignificant. That is an indication to go to your big correlation matrix table and have a look at 2x's, if 2x's don't have a high correlation coefficient. And then the zero conditional mean of all of these is probably the most difficult one, the most problematic one, especially in panel. So let's talk about the detail just now. But when all of those three are in place, we know that our OLS parameters will be unbiased. What does that mean? An unbiased parameter. If I have that beta parameter will have a distribution, kind of a bell-shaped distribution. If this is the actual beta and I get an estimated beta like this, that beta is biased downwards. So in plain English, it means the parameter is wrong. So we have to try our utmost best, and I think we can write it like this: in the limit, the estimated beta approaches the actual beta, and then we can say that that beta is unbiased. So the things that will make it biased is if our functional model specification is wrong, or even the data is suggesting this is a nonlinear relationship, like inflation and growth, and we just force a linear model on it. Or we actually apply to the Cobb-Douglas production without logging it, something like that, some functional form error. Some X variables that are correlated, right-hand side variables, regressors or independent variables, or explanatory variables, or the zero conditional mean. That is violating the exogeneity assumption. We'll discuss the detail of that just now. Then, two things. What is this suggesting? Where does that problem occur? 1, 2, and 3 is about the betas. 4 and 5 is about the residual. So the first three assumptions has to do with getting that parameter right. And of course the intercept, but we know the intercept is also alongside the residual will collect some of the measurement errors and misspecification errors and so forth. However, the other two assumptions has to do with the residual term. The heteroskedasticity is the one, if we plot the residual term over time, where we get like the variance is not constant across the whole sample period. So we can say sigma square of u is that variance has a t. It depends on the time period. So that is that's violating the assumption of homoskedasticity. The residuals are heteroskedastic, and then in terms of zero correlation, we kind of see a pattern that the residual is a function of the previous period residual. So if the residual goes down over time, it goes down for a while and then goes up. So why is this problematic? It is problematic because the standard error associated with that parameter is biased. So the t-stat is biased and the p-value. So your inference is impacted. So that is important. So the first thing is important to get the right betas. That we don't get, we think it's 0.8, but it's actually something higher or lower. Whereas the last two is more a suggestion that the inference will be valid. We're almost at lunch. Which do you think is is one more important than the other one? I think if I ask you, half of you will say, I want right parameters. The other half will say, I want to be sure about my wrong parameter. How should we think about that? What is it more important to have the unbiased beta, but you're not sure about that t-stat that you get? The distribution can be something else. The t-stat is biased. It's too high or too low. Yes?
Yeah, I think that has to do with the type of the data that you are able to access into, like whatever you're taking into. It can also depend on the number of variables available to you. So, like, I think those factors are the ones that will determine whether they're right.
Obviously, we want to have all the boxes tick, or fail to reject all the hypotheses that.
In those situations, you might find that you're very, very right.
Yeah.
Accounted, but now still you have maybe other ownership that
Yes.
affect you.
Yeah.
So you don't account for those variations.
Yeah, I think this is one of those answers where we can say it depends. If you're kind of pretty confident of your theoretical underpinnings, if you know that there must be an income variable, there must be an interest rate variable in a money demand equation because that measures the opportunity cost. But now you don't get that interest rate significant. But theoretically, you know it must be there. So it can be that all of these structural breaks going on, now it doesn't show up significant. So in that sense, if we can rely quite a bit on economic theory for the specification, it's nice to know about that our parameters are unbiased, but it's never a choice. We want to work until we know that we don't violate any of them. And the good news is, if you run an error correction model and you go through the motions, it is very, very likely that you will be able to fail to reject all of the nulls. no zero correlation, no heteroskedasticity. Sometimes we struggle a little bit with the Ramsey reset test for specification, but if you then just go back and add or subtract some of your dynamic terms, you get it right.
And another thing, like maybe like one that needs to consider is sometimes those models, the results, doesn't much tell us what makes us.
Yes. Yes, that should always.
They have nice results, and you find that there's no contributions that you are driving with
Yes.
analysis.
Yes.
It is there.
Yes.
You know, looking beautiful on a paper, but
Yes. Yes.
So yeah.
It's absolutely true. Sometimes you just have to settle statistically for something that is not 100% what you want, but having the economics. So if we think about a dog and a tail, the dog must wag the tail. The dog is the economic model, and statistics, we think of that as the tail. And then finally, the normality of the residuals then helps us to be able to believe the t-stats and the f-stats and the r-squared, that those distributions are valid. And that's what we want. There's a little bit of detail. Maybe I can just go very quickly through the, this is simply saying again that linearity in the parameters, no collinearity, so no perfect linear combination of independent variables. If we run a fixed effects model, a panel model, say we have 10, or we have the 16 countries in SADC, and we run a fixed effects model of that, and we control for those heterogeneity using fixed effects. And if we then want to control for all 16, what happens? You get that message, near singular matrix. Because all of those dummies that we use to account for the country heterogeneity, they add up to 1. And it's perfectly collinear with the intercept term, which is a column of 1 times the alpha. If the alpha is 3.14, that 3.14 is perfectly collinear with a constant for the fixed effect. The zero conditional mean. This is the typical, we write it formally that it is when you have, there's some correlation between the x and the error term. The textbook example is where you have wages as a function of numbers of years of experience and education. And then we find that education is then correlated with something in the error term. But what is hiding in the error term? Is it really just the fact, the numbers of years that you sat in classes that should, it's important for the wage that you can earn, but is it not more than that? Is there not something else? Why do somebody move up the ladder quickly? Is there something that person brings, like spunk, that Hausman refers to that in his paper that he wrote in the 70s. Said some people just have spunk in the workplace. You can all think of somebody in your team at work or where you study. If you have to do group work, one will start out with a long face and say, oh, I don't think we can do this. Why do we have to do this? This is so difficult. And the other one will just say, I'll do this, I'll do that, let's do this, let's do that, you know, and you get people in the workplace like that as well.
Yeah.
So there's something, it's correlated to what you've studied, the number of years that you've studied, but some people just bring something additional. And then that, what's hiding in that error term is then correlated with this numbers of study or that education. And that causes then a problem, that beta in front of the numbers of study is then biased. So that's where we then find an instrument, the typical textbook instrument of mother's education or father's education, which is not correlated with your income, but it's highly correlated based on the assumption, I also question that, based on the assumption that there's a correlation between parents. I think in South Africa, we're still in a phase that many of the, if you like, my generation, the parents didn't study, and now it's important for them to have their children to study. So that's not that, so it may not be a valid instrument. So, but that's the idea. But there's more things than that. It is also feedback effects and simultaneity. And that's what we deal with a lot in macroeconomics. Growth, inflation, or investment and output. Am I over time now? Let me just, we're almost done. The difference between, and this is the only difference between the condition in cross-section. Otherwise, it's exactly the same for cross-sectional and for time series applications. Because here we assume we can have contemporaneous exogeneity versus strict exogeneity. And the difference between that is this is just same period error term, same period X. And this one is then for the error term, but it must be independent of with all X's. So if we just have contemporaneous exogeneity, the beta parameter is consistent, but we need strict exogeneity. And that's quite a strict assumption to reach. And then homoskedasticity, we can think of it simply as those pictures that I've drawn, that the variance is not constant. It must be constant. Otherwise, the standard errors will be biased. And zero correlation, there must not be between one period and other periods. It must be well-behaved, white noise, with a zero mean, no zero correlation there. And we can skip this proof. And then lastly, just normality. The error terms must be normally distributed, and then we can rely on those statistics. And we have tests for all of that. In a practical sense, it becomes like a battery of tests, just a set of code that you run, or you click through the test and you want to see, in this case, large p-values, because the null is no zero correlation. So if we want to see a small p-value, that means we've rejected that and we don't want to. And then, just a little bit of dummies. We will have enough time to talk about dummies. The South African economy is a very good case study of structural breaks. But then again, if you think about the UK economy, it almost feels to us looking from a distance. If you look at the series, it's very smooth. But David Henry published a paper on UK consumption over like a century of data. And he used so many dummies. It's like this was a period of where consumer confidence was depressed, and here we have a war, and so. So he had like 60 dummies in a 100-year period. And to me, it's like, he's such a rated, well-known economist. It feels to me that that's too many dummies. And that's not what we, but I mean, if you really want to tell the stories, some of the papers that they wrote was they also ranked events as having a large, medium, or small impact, and do it that way. We will just try to be as scientific as possible. And yes, here's the example, Sean, where this is a housing investment as a function of the price. So this is like, you think this should work, but why is the sign positive there? Up the price and you will get more investment in houses. People will think now is a good time to buy a house. Is that what that says? So Woolrich says, no, but just put a trend in there. Then you get a plausible result. For me, just adding a trend there, what that trend actually is for me a proxy for the income effect that's not there. So a missing effect can actually even switch the sign to a wrong sign. So, yeah, econometrics is difficult, but it's rewarding. And it's as much a science as an art, and learning by doing and collaborating, and look at what has been done, and that's the end of this session.